Hey guys, today we're going to take a look at the Pythagorean theorem, everybody's favorite theorem. So first of all, Pythagorean theorem is used when there is, I'm already making mistakes, okay. When there is a right-angled triangle, that's weird looking H, but that's okay. Right angle triangle, okay. We also must know two sides. Okay, and of course we will use it in order to find the third side. So the first example we're going to look at here is a fairly straightforward one. Okay, so the first thing you're going to do is you're going to label your triangle with A, B, and C. Now this one gives us A, B, and C as angles, and we're just going to ignore those. So just ignore those, pretend they're not even there because they're not actually going to help us. So what you're going to do is you're going to start by labeling the hypotenuse. Now remember, the hypotenuse is the longest side. It's also directly across from the right angle. So this is our hypotenuse, and you must label it C. Okay? The A and the B are the other two sides. It doesn't matter which one you label where. Okay? Now we have a squared plus b squared equals c squared as the version of the formula we've got written there. But whenever you're solving for the hypotenuse, it's a little easier if you start by writing it backwards. We're solving for c anyway, so let's start by writing it out like that. Okay, and this will just make our life a little easier because there's less to do. So we start by plugging in our numbers. So we get 40 squared plus 9 squared. Okay. And we say 40 times 40 is what? And it is 1600 plus 9 times 9, which is 81. And you add them together and get 1681. Now, most common mistake made on Pythagorean theorem questions is that we get to this point and think we're done. But we are not done because that is c squared, and we are not looking for c squared, we're looking for c. So you must take the square root of the number. Okay. You can use your calculator for this, of course, and this will give you 41. All right. And the last thing we have to do is give ourselves a unit, which in this one was meters. So there we go. So C is equal to 41 meters. All right, so let's take a look at this slightly more complicated one. And this one, we're not looking for the hypotenuse. It's always a little easier when we're looking for the hypotenuse, but it's not that much different if we're not. So you're going to start again by labeling the hypotenuse. It's the longest side. It's across from the right angle. Okay, and we'll have A, we'll have B. Okay, and we're looking for B in this case. So here is a case where we are going to write out the more common version of the Pythagorean theorem, a squared plus b squared equals c squared. And the reason we want to do that is because we're solving for B, which is now on the left side, which is a little easier to work with. So we'll leave the b squared where it is. We'll move the a squared to the other side, and we'll be left with c squared minus a squared. All right? And now we're just going to plug everything in. Now, actually, I wonder if I actually should have, I'm going to go back and make a slight change to the last one that I did, because in actual fact, what I should do is not use C anymore, because in the diagram it used a Y. So what I actually should have done is at this point I should have changed that to Y squared. Okay, so we'll make that change, and then we have that Y equals 41, which is what the question actually asked. So whoops, but we got it. We caught the mistake, so it's no big deal. So here we go for this one. B is actually an X in this case. Okay, so now we'll just go up and look, and we say, what was C? C was 13, and A was 5. All right, so now we just go through. We say 13 squared is 169, 5 squared is 25, and if we subtract 25 from 169, we will get 144. So we get that x squared is at 144, which again, that is not what we're looking for though. We need to find x. So we're going to have to take the square root. And this one you might actually know without a calculator, that's going to be 12. Okay, and the last thing to do is check our units, and they were centimeters. And so there we go. We're all done. All right. So let's do one last one here. This one's a word question, so sometimes we think of these being a little more difficult. So we're leaning a 9-meter ladder against a wall, and it's going to go 7.9 meters up the wall. And we need to figure out the distance from the base. So the first thing we're going to do is draw this diagram. Does your diagram have to be perfect? No. Does it have to be to scale? Of course not. If it was to scale, we could just use a ruler and we wouldn't have to do any math. And what would be the fun in that? So there's our wall. We lean our ladder against the wall. Of course, the wall makes a 90-degree angle. Okay, so this is our ladder right here. We'll make it blue so that it's clear that that is our ladder. All right, and I've already forgotten the measurements. So it was a 9-meter ladder and 7.9 meters up the wall. So this was a 9-meter ladder, and it went 7.9 meters up the wall. So all we have to find here is this distance here. All right, so we're going to start by labeling our triangle. So we'll label our C first, which of course is the ladder because that's the longest side, and once again across from the 90-degree angle. And we can label this side A and this side B. If I did that backwards, it wouldn't make a difference. So we will say, so we're going to go back, we're going to use this version of the formula again because we're not looking for the hypotenuse. And this time we're looking for A. Okay, so this is going to be exactly the same as the other one, except that we're looking for A, but that's not really going to affect anything. We're just going to say A squared. And actually, you know what? Never mind. Let's do it. I was going to sub numbers in and then isolate. Let's isolate first. So we're going to move the B squared over to the other side. Here's what I did on the last one, so I don't know why I started doing it differently. Okay, we move the B squared to the other side. It's now a negative, and now we start plugging in our numbers. So C squared was 9, or not, C was 9 anyway. Okay, and then we had 7.9 squared. All right, so that's going to give us 81 minus 62.41. Okay. And that's going to give us 18.59. And once again, we are not looking for A squared, which is what that equals. We're looking for A. So to find A, we're going to have to find the square root of 18.59. If you can do that one in your head, I will be very impressed. I had to use a calculator to find that it was 4.31. Okay, and then we will add our measurements, but we're not done this time because, of course, it's a word problem. So we have to say, therefore, the distance from the wall is 4.31 meters. It's always important to make sure that your therefore statement does indeed answer the question that was asked, which it does say how far away from the base of the ladder from the wall. So the distance from the wall is 4.31 meters. Does indeed answer it, although I am realizing that I rounded to 2 decimal places and it says 1. So we will correct that just by rounding it there. And we'll make it 4.3 meters. And there we go. Okay, so that's it. So until next time, go Sabres.